Before I begin, BruCON, thank you for having me here, and all to my colleagues at KPN, thank you for involving in this research. My name is Jaco Blokker. I've been working at KPN as a security analyst for more than 6 years. And it's my job to protect KPN and to protect its customers. And therefore, I spent a considerable amount of time on sifting through the logs, analyzing events, developing detection, tuning detection. And among other capabilities, we have a detection platform called Snort, and which is based on Snort. And it happened on one day that a colleague of mine came up to me and said, "Did you detect the attack that was launched by a red team against our domain controllers?" So then I queried our event history and looked for it. Well, guess what? Nothing could be found. Well, he asked, "Did you at least have a detection pattern for it?" Again, I queried our rule base and looked it up. No luck again. Damn, we missed it. What an embarrassment. So can you see my frustration and annoyance around that time? We missed it. We were unable to detect it. So we considered several options. I searched the internet for an alternative, for some rules, so we could implement it on our systems. Pretty much could be found on detecting Windows management instrumentation on an endpoint level. But very little could be found on detecting it on a network level. So then we decided, okay, we can sit and wait for a defender to deliver a fingerprint, or we can deliver and produce our own. So we did. So after a few months of hard work, we produced a rule set, and we decided to release it to the public, to you, the community. Now, in the beginning, I had some doubts whether or not I should share it. Because on the one hand, it offers a potential attacker insights into our detection capabilities. On the other hand, is it perfect? Are we done? No, no. So I hope it is useful to you as it was useful to us. And if you can come up with improvements on this rule set, well, please share it. Sharing is caring, right? In this talk, I like to focus on our methods, our approach. What worked for us? What did not work for us? And as we can see, there will be some open ends that need to be sorted out. So please, let's consider this as a starting point for future improvements and for future enhancements. Let me see. Please raise your hands up if you are familiar with the history and background and the characteristics of WMI. It was in the mid-90s when the Microsoft and the Cisco sat together to address the problem of uniform management of machine components in an IT environment. And they set a few goals, high-level goals, and it was named Web-Based Enterprise Management. But to make it more practical, it was tied together with CIM, the Common Information Model. And the Common Information Model describes specifications, schemas, naming conventions, and the relationships between all those machine components, objects. And soon after that, Microsoft, as an early adapter, implemented its own instance, and it was called Windows Management Instrumentation. And soon it became available to Windows NT. Because it can be considered as a core OS component, it became available in Windows 2000 since then. And with WMI you can read, write or execute remote commands. Or you can read, write objects. And by default, when you're a member of the local administrator group, you are allowed to have access remotely. And by default, it's blocked, at least in the recent versions, by default on the host-based firewall. Now, while the future, considering the transport, is web service management, implemented as Windows remote management, this talk focuses on the transport RPC DCON. Yes, I know, it's legacy, it's less firewall friendly, but it's there. So should I care as a defender? So let's consider the different perspectives there are, like the perspective from a system administrator. It offers great potential for a system administrator to administer his or her environment. But if you can use it, you may misuse it. And if you can misuse it, I like to detect it as a defender. But because it's a core OS component, that implies also that is there a need for an attacker to bring WMI as a tool with him? Maybe, maybe not. So that poses another challenge to the defender. How to distinguish between the legit part, the legit traffic, between the non-legit part. Is this just theory? Well, just have a look at the MITRE ATT&CK framework. The MITRE ATT&CK framework presents several examples of actors, threats out there who are known for leveraging WMI. So therefore I consider several monitoring objectives. Is it doable to develop detection of WMI? Can we do it? Can we make it? And our focus is also focus on detecting non-legit traffic, not on vulnerability detection. And we focus on a network level detection. And once an alert triggers, if we can make it and if we can produce it, how can we supply additional relevant data towards a security analyst? And it might involve things like who did what credentials were used, what commands were executed, or might it be possible to detect attempts to abuse WMI? So how did we start? Simply as this, without a sound understanding of how the protocol works. We sat together, we grabbed our laptops and attempt to execute this command, taken from the Windows Management Framework, get WMI object, targeting to a remote system, and attempt to execute ipconfig.exe. And yes, we knew we used credentials, we were forced to, but we also knew they were not valid. And after multiple attempts, I was presented with a packet capture typical like this. And it shows me that the client attempts to connect on port 135, which is known as the end mapper port. And the client connects to an interface called the Object Exporter ID Resolver. And as many of the other objects within RPC, these objects are assigned with a well-known unique identifier. It's called the UUID. And this is a 128-bit number. And the Object Exporter ID Resolver is capable of doing garbage collection and basic RPC bookkeeping. So this looked like to me at that moment in time a good starting point for me to develop a first rule. So it became this. Now at that moment in time, I asked myself, what would be the risk of a false positive when I would deploy a rule like this in production? Please raise your hands if you think the risk is quite high. And who says the opposite? Very low. Okay, quite imbalanced. Well, the fundamental problem I had with this rule was it lacked context. The rule like this would instruct our IDS to look for this specific byte sequence in the entire payload of a packet. But was this really what I want? No. I just want to look up the sequence, the interface identifier in the packet in the RPC context. However, this rule does not. So how can we instruct the IDS to look for that context? Well, let's consider a typical function call in terms of RPC. The client calls a function, also known as a method. It gets passed some parameters. It will hand it over to the stop, and the stop takes care of conversion between the client and the server live in their own address space. It will put it on the wire, and the server will receive the request and will do the reverse. And then back and forth. Now if we map all these steps, of most of the steps, on specific patterns the IDS is capable to look for, to search for, I would come up with this. It's the I phase, the interface number, it's the operational number, which matches the method, and the stop data. So that made me transform my latest version of the rule into this. As you can see, this is far more readable. And as I expected when I conducted the test, the rule triggered again. And as an additional advantage, for me there's no reason to worry about whether it's not big endian or little endian, because the interface identifier can be presented as a little endian or high endian. So that would save me from writing an additional rule. So, arrived to this point, we have a first detection pattern defined. But how can we distinguish between the ledged and the non-ledged traffic? We didn't address that so far. Now, me as a defender, or a defender in general, in a large enterprise, how can a defender find that out? I counted my way, so what I did was engage with our system administrators, and especially the administrators that are responsible for maintaining the assets we want to protect. So, my question was simple as this. How do you administer your machines, leveraging WMI? Unfortunately, they had a policy on their own. And they said, yeah, we have those machines, and typically we agreed with each other to administer those machines from these sources. So this became a blueprint for my next improvement for my rule. Now there's a pitfall somehow. If you consider this as a one-off exercise, this can mean that and result in false positives when it turned out that the administrator would add or remove a machine from his farm. we like to protect. And combining our very first payload pattern and our policy we have obtained would result in a rule like this. And our very next step would revisit our red team to conduct another test. Now, why would I do that? I did testing on my own, right? Well, I thought by myself, this is to get around my own blind spots. So the red team, my colleague, used several clients to test, like Windows PowerShell, like we did before. And he leveraged a open source network protocol library called Impact. And again, he used an unauthorized account. And from these tests, it appeared that the Windows client triggered the rule as expected. However, using the Linux client, using the open source library, it did not. So how could I get around that? So that made me realize at that particular moment in time, maybe I have been considering the problem from a wrong perspective. What are we supposed to protect? Is it the client? Clients? Is the server? What we like to protect are the servers, our domain controllers. So that made me ask myself, what can I consider the authoritative source of how a server should behave in a network? So I queried the internet, searched the internet, and I came across this article. It is part of the Microsoft Developer Network, and it provides a specification on the WMI protocol. Now, this made me happy. It says like, the client must call NT11 login method. And the interface must be uniquely identified by a specific, unique identifier. Or if you prefer a more visualized version, it will look like this. Now, knowing this, would following this approach cover what we have seen before when the red teamer used the open source library? Well, because it's open source, I can look up the source, and it shows me that indeed the open source library leverages specific references we have seen before in the picture before. So that made me to develop another rule set. And I distinguished several categories, like the RPC states, and I signed it with a different color, the color gray. And I defined another category called WMI. And there was a source for inspiration for another rule based on the IWM level with the op number 6. And this is the rule we have seen before was, okay, this must be called for you to succeed. So let's call this a golden rule. And assign it with a color yellow. So my rule set became like this. We have a RPC stage section, I have a WMI stage section, and as an additional bonus, I developed some other rules based on other identifiers. But still we don't have covered how to detect brute force attempts or failed attempts. And it might happen that the WMI section, the rules in that section, won't trigger. But me as a defender like to know what is happening on my network, on our network, when some bad guy out there is trying to access machines leveraging WMI. So what I did was execute typical commands leveraging WMI and used invalid credentials. And based on the packet capture, it will present me capture data like this. The server responds with a denied response. So then I look up how a typical packet, the packet's anatomy, could look. And when I look up the documentation, it will present me like this. It says, okay, when the server replies with a denied packet, a fault packet, this is a structure of such a packet. And the code you're looking for, code number 5, is located on position 24 and in length 4 bytes. So therefore I came up with a rule to detect that. And it says, okay, compare the value you found on position 24 in length 4 with number 5. If that matches, if that's equal to 5, then we have a hit. So now we have a rule set, a improved rule set. So now it's time to test our rule set. I didn't expect it was that easy. Maybe you can imagine there's always, there might be some friction between the security and operational department. But we were helping them out. We were not saying security says no. We're helping you out. We're helping you protecting your assets. So they showed great willingness to get involved in testing our rule set. And it made them come over to our office location and spend whole day on testing the rule set and become aware of the importance of this rule set. And basically the test plan they used was composed by this. They used several recent Windows versions, they used several clients, they used both unprivileged and privileged. In the latter one, we didn't do that before. And they documented the results from this test, whether it was success or it was a failure from a user perspective. And we would present it with the results like this. And I've presented it as a binary heat map. On the y-axis, you can see all the different rule categories are plotted against the use cases on the x-axis. And whenever a rule will trigger, this would result in a black box. And it will mean that at least once a rule triggers. Now what strikes me the most from this picture is that my supposed golden rule indeed correlates nicely with all the successes based on testing. However, at the same time, my reject rule, I'd crafted, did not trigger. So what is going on? So I started tweaking the rule, and after many iterations and looking up the documentation, I came up with this. Maybe I missed the point. Maybe I went wrong somehow. But this is the best I could get out of it at that moment in time. Now, I need to be aware that it's quite common for a client-server negotiation that a server might deny a client proposal for some protocol specifics. But that doesn't mean there is something going wrong in terms of an attacker is attacking your systems. So I would recommend to use this rule on its own as a rule in combination with a threshold. And maybe there's a better source of inspiration somewhere higher in the stack to identify attempts or brute forces. So consider this as one of the open ends I can come up with. Now we have a improved rule, a new improved reject rule. So it's time for retesting. And what we can see now is my improved rule did trigger, and did trigger on the use cases where we know that the golden rule did not trigger. And that's nice. This made me happy. So our very next step would be, okay, we have an improved rule set, and to engage with our system administrators and the red team. So at this point, would we be confident to deploy our rule set into production? So suppose you're the security analyst. What would you do? Would you deploy the rule set as it is in production? Please raise your hand if you say yes. Go for it. Well, quite critical. So what could be the number one major concern of a security analyst? Any suggestions? Distinguish between legit and non-legit. Okay, okay. Any other suggestions maybe? Well, let's say false positives and false negatives. It may happen that a security analyst gets flooded with false positives. He doesn't like that. A few of them he can handle. But when it would appear there will be more, it causes a lot of work. And it might happen that some real attack is staying on below the radar because it's overwhelmed, it gets flooded. But to stay on the positive side, at least we have a trigger. So we have a trigger to improve our rule that was involved in the false positive. So let's move on to the false negative. How do you find out as a security analyst we have encountered a false negative? When do we find out? Any suggestions? Right, excellent, after incident. And maybe when the incident reaches the news headlines, which we don't want, right? So what can we do more proactively to find out if a false negative appears? So let me do a suggestion. Let's assess our rule set quality. So how can we do that? Suppose you're the security analyst, what would you do in order to find out if our rule set is susceptible to false negatives? Well, what I did was, what can an attacker do in order to evade RDS detection? Now, I hadn't a clue about that, so I looked up the documentation on what is WMI security about. And I came across this, and I summarized this over here. You can secure the namespace of WMI. WMI consists of several objects. And it can be secured with access control list. But since we focus on detection on a transport level, what can we do in order to secure the transport level part? Now there are several things which we can do, like impersonation on DCOM level. But the most relevant I found is what can we do in terms of authenticator level options. And it appears that several levels of authentication can be applied. And it varies from none to backup privacy. And the default is considered connect. And connect means it authenticates the client and the server credentials. But it does not encrypt data. And backup privacy is the only one level that encrypts data. So if we found out that connect is a default, is there a way, I ask myself, how we can force a client and server to use the maximum authentication level? And we can do that leveraging a tool which is available on Windows, which is called DCOM configuration. And it presents a user interface to the registry. And both process-wide, service-wide settings can be applied, but also machine-wide settings can be configured. So then what I did was set up my own lab environment, my pristine lab environment, as we wanted to stay good friends with our operational colleagues. And the lab environment consists of recent various versions of Windows, like a domain controller, a member server and a standalone machine. Different versions. And I used a Linux client, again based on the impacted library. And I started with a very first use case with a default settings. And my approach was, after that, force a higher level of authentication on a client level. And after that, force both client and server act on a higher authentication level. And then I used server-client methods, like this. So the first two were obtained from the Windows Management Framework. The first was a command line tool that enables you to use WMI. The for command was taken from the impacted distribution. Number 5 was taken from the Kali distribution. And I used several use cases to force invalid passwords, invalid usernames. So I was curious to find out how would the behavior be on a network level. And similar as before, I was presented with the results over here. Now this is the default level. And what strikes me the most from here is my golden rule triggers across all use cases. And apparently it did not trigger on the reject use cases, as I had expected. So far, so fine. But let's consider number 1. It shows me some rejects, while it appeared that my golden rule triggered. I'm not worried with that. And also, let's consider use case number 2. When I would use the command line WMI tool and the Linux command line tools, my very first RPC handshake rule does not trigger. Well, my golden rule triggers. And so far I couldn't make sense of it, what happened there. I attempt to retest and it disappeared. But when I would retest it again, I found out, the upper C rule I had did not trigger. So it's not very consistent. And especially number 3 is quite interesting. No single rule from my rule set did trigger. So was this a false negative? Maybe, maybe not. Because when I traced the packet capture, no sign could be obtained from the capture. It might be a mistest. I'm not quite sure about it. So let's move on to force client level encryption. So I'll leverage all the commands I had before using a higher authentication level. And it appeared to me that, again, my golden rule triggered across all use cases, with the exception of one. Well, that's doing research. It may happen that it doesn't trigger. So it maybe needs some retesting. But the funny thing here is, when you compare it with the results on the slide before, is now my command line WMI tool does trigger twice. So let's move on to, let's force encryption on both client and server side. Well, then it appears to me that my golden rule, which I hope to trigger, does not. While using my Linux clients, it does trigger. That made me curious. What is going on here? So I looked up the packet captures, and some traces were found. And those traces were my source of inspiration for a new rule, an additional rule to add to my rule set. So my new rules I added were these. And then it's time for retesting. And as you can see over here, these rules triggered. So now we have better coverage for our attacks. But you may ask yourself, and I wondered, how likely would this situation be? Would it be likely in an enterprise environment for forcing a higher level of authentication of a Windows server? Or would it be more likely to use the default settings? Well, you may answer the question yourself for your environment. I would assess it as less likely. So, what were the takeaways from my research? Considering the scope, it is doable. We delivered the results, we released to the public on GitHub. Please have a look. We found out that cross-team collaboration was very helpful to get around my own blind spots and to make administrators aware of the importance of detection. And when they would find out some machines would be decommissioned or will be added to the farm, let's notify the SOC in order to prevent false positives. So I was quite happy with the rate on false positives. But false negatives may be a concern. I just did limited testing. But if you have some ideas on what we can test more in addition to that, well, please let me know. Let's share. And maybe there are some other alternatives, other techniques that can be used in order to evade IDS detection. And as you could see, there were several open ends. Maybe I missed the point, and maybe you can come up with how to get around that. So that brings me to my final thoughts. One sunny day, a few lacking rules became a big takeaway. To overcome the annoyance and frustration, with the support of both admins and reds, we fulfilled the promise. Nothing is beyond our reach. Now it's time to call on you to have a look and make it better. Administrator, defender or attacker, the role doesn't matter. Suggesting to combine it with a Belgian beer, let me say loud and clear, I feel confident we can work it out together. So if you have questions, I will be happy to answer them. That's correct. Yeah. And that is to say, based on source destinations from an operational perspective. What we can expect how they would administer their machines. So the question is, can we have a look at what commands are executed that can be presented in the packet capture? Yeah, that could be another one. Yeah, and maybe another suggestion could be like we have seen that a client and server could handle different authentication levels. But is it common for an enterprise to have just encryption-less traffic in an environment, or what would happen if someone else could force higher authentication level with probably encryption inside it? Hey, we don't use that. You could argue about that, would it be wrong or would it be good, but that's different. It's an anomaly, right?